Hey, before we get started, if you're in the back, would you mind just coming up a little bit? Because I know when the sound gets kind of messed up, so we've got a lot of empty seats up there. Sorry to make you move, but it'd be really helpful. Awesome. Cool, thanks guys.
All right, so we'll get going here. So my name is Scott Erven. Just a little bit about my background. I work with Protiviti. I'm associate director. I specialize specifically work in healthcare security and medical device security. So I'm also a security researcher. I've spent just over 15 years IT information security. And not only am I a researcher consultant as of recently, but I did spend 5 years working with healthcare providers and running information security teams. And that's kind of where I got, close or got a passion for looking at medical devices was really when I was working in the healthcare environment and seeing these devices become connected, that really affect or can have an effect on, patient safety or human life ultimately. So I spent over last 3 years, researching various vulnerabilities inside of medical devices, giving quite a few talks. So we'll cover, some of those phases of research here later in the talk. There's my Twitter handle if you want to hit me up on Twitter. Let Adam do a intro here and get us going.
All right. Thanks, Scott. So my name's Adam Brand, also with Protiviti. It's with Scott here. I've been in technology and security for a while. How I got interested in this stuff was through a group called I Am the Cavalry, which I don't know if many of you guys have heard of. We're looking at issues of security as it relates to human safety and human life. So for the past year or so, I've been focused more on this topic. So our agenda. So what we're going to talk about. Awesome, thanks. So first, we're going to talk about why research medical devices. Right? There's a lot of stuff out there you guys could look at if you're thinking about doing a talk. So why focus on this area? Because we think you should. We're going to get a little bit into the research that Scott's done, phase 1 and phase 2, looking specifically at first at medical device specific vulnerabilities, and then the exposure of those same systems on the internet and what that looks like. We'll talk a little bit about application security, and then we'll go into what do we think the diagnosis is, what are some of the root causes of this, and what's the treatment? How do we think that this can be solved? So first off, why as a researcher should you look at these devices? For one thing, some of us actually depend on medical devices to live, right? So if any of you are out there are diabetic at all, you may have an insulin pump or a glucose monitor that's important, right? If you don't have that working appropriately, or if that's hacked in some way, it can affect your life. In fact, one of the researchers who's been looking into a lot of this stuff, Jay Radcliffe, got into it because of his own personal device. So for some of us, it's super personal, right? How many of you out there have been in a hospital as a patient? Right? Yeah, so most of you, right? So, when you're in the hospital, it's when you're most vulnerable, right? You're there, you're dependent on the doctors to see you through whatever procedure. There's all this equipment hooked up. And at that time, you're really at a stage where, if something happens with the computers or the equipment that you're connected to, you're kind of at their mercy. So a lot of this is for us as individuals. You should care because you're going to be in a situation someday where this might matter very personally. And then if you haven't been in the hospital, obviously you have people that you care about that go in for procedures and things like that. I know for me personally, about a year ago, right after I started getting into this I'm the Cavalry stuff, I was going to the NICU. My sister-in-law was having twins, and they were premature. And so she was in the NICU, and they had the heart rate monitors out, and they were trying to find the fetal heart rate, to see how the babies were doing. And the nurse was having trouble with the device, and she's like, "Yeah, these things are so flaky," and she was complaining, and she's like, "Yeah, I might have to reboot it." I was thinking, reboot it? What? But yeah, it freaked me out because I looked and she kind of tabbed out of whatever application this was on the screen, and it was running Windows XP. I saw the cloud background. I'm like, oh man. you know? And it's like, that's really what you want to see when someone you care about's in a situation like that. I'm thinking, you know, it's like, what's going on with the security of this organization where they have this, you know, outdated, potentially vulnerable operating system, potentially running Conficker, right? I mean, it's just sitting there. So this is another reason why you should look at this. There will be a personal impact for yourself or someone that you care about, you know, sometime in the future. And then there's also the professional impact. So what does this make sense professionally, right? You're going to get out your hacker hoodie, sit down. There's plenty of bugs to find in this space. So this is not looking for those tiny, nuanced bugs that's going to get you this and it's going to get you that, and you have to do a ROP chain and all this other stuff. These are, you know, admin is the password for this, you know, whatever, right? You can do a talk on that. There's a lot of bugs to find. They're not super complicated from a domain-specific knowledge a lot of the time. So you can take what you've learned and what you've researched in other areas and apply it to this area. Just put yourself like 10 years back in time, what would have been the hot topic, and that's what's a hot topic in medical device security, right? There's a lot of work to be done in this space. It's a lot easier to explain the impact of your research too. So there was a talk earlier about, you know, how do we change the perception of security researchers and hacking, and how can we communicate better with reporters? And part of it is, you know, taking technical language and putting it down in an area where a reporter can understand. Well, in a lot of cases for these are very visceral and very easy to explain. You know, you're not trying to explain a Chrome sandbox bypass, ASLR, hop, SEH, whatever, right? I mean, you're strictly looking at, from the things that you can look at, you could say, oh yeah, I figured out a way to make, you know, drug infusion pumps dispense the wrong drugs, right? I mean, I can figure out how to OD patients in this hospital. That's very easy to explain to a reporter. So what are we doing right now in this space as researchers and as security professionals? So a few things. One, we're looking at what the scope of the problem is. So we're starting to do these assessments, starting to look at devices in different areas, look at different organizations. We're also getting into the notification. And this is a really interesting process that Scott can tell you a lot about, but a lot of these manufacturers are not familiar with vulnerability disclosure processes. So we're helping through that process, hand-holding in some cases, facilitating in other cases. And then at the end of it, also public awareness. So we're trying to inoculate against future issues by bringing this issue to everyone's attention now before the device manufacturer decides that they want to put Bluetooth on your pacemaker, right? So now Scott's going to talk a little bit about the research that he did in phase 1 and 2.
Yeah, so when I first set out to this, I was really looking, you know, device-specific vulnerabilities, and I was looking, you know, across like all modalities inside of healthcare. So what I mean by that is you're looking at everything from infusion, insulin pumps, all the way to, you know, defibrillator, pacemaker type technology, X-ray, radiology, all the way up to, you know, critical like radiation oncology devices like linear accelerators and those types of things. So I spent 2 years, you know, looking at the security of all these various types of systems. And in a way, I kind of felt like, man, did I waste, you know, like 2 years of my life? Because I came up with 3 bullet points here that really is basic security hygiene items, that the attack surface was there, and it was very easy to get administrative credentials into these systems. So the first one that kind of wraps up is hard-coded or default, you know, service credentials. So what does that do? Well, that gives you administrative access. So basically, anything that that physician or that nurse or that clinician can do, if they put it into that application incorrectly and it causes patient safety issues, you can do that as an attacker once we get administrative credentials. So treatment modification, configuration changes on these devices. Those are the types of things that you see. Now understand that there's a very good, shouldn't say a very good reason, there's a logic to why what is there is there. And historically we didn't think about those unintended consequences. And so the reason there's hard-coded passwords is obviously from a support perspective so that these specialized support technicians have no troubles getting into, you know, critical devices when you're laying on the OR table. So there is a balance here that's a little bit unique to healthcare, right? So know that a lot of these, there's a reason why we did it. We just didn't think through it in the unintended consequences. And sometimes, even if you think through it, there's not a good answer. The risk doesn't necessarily, the treatment and the device outweighs the risk. There's also known, software vulnerabilities. So I think Adam was saying on XP, something that's common. I'm going to show you an example here coming forward, but it is kind of rampant, across the board on a lot of these legacy systems that they're running vulnerable versions of XP. They're not being updated inside the environment. Is there anyone here in healthcare? A couple of people? Yeah, then, right? Yeah. So there's devices that are running, legacy systems that sometimes get pushback potentially from the manufacturers. It's getting better, but those legacy devices, they exist. Thirdly is unencrypted data transmission. And at first, I like to focus my research on patient safety and look at it through that lens instead of patient privacy. Patient privacy or privacy in general is really important, but ultimately you got to be alive to enjoy it. So the unencrypted data thing, a lot of people think, oh, that's a privacy issue. Absolutely, it's a privacy issue. But some of these devices, how they operate, medical device integration is a great one. So with meaningful use and those types of systems, we now need to dump, and doing like population health management and data analytics and big data inside of healthcare, we need to dump all the data from what were critical devices that traditionally weren't on the network. So you get into like anesthesia carts and ventilators. They were not network enabled before. But you relate that to, okay, there's a lot of people that die on ventilators. Is it really they're dying from pneumonia, or is there something there? Well, we need the data. Let's plug it in. So now these types of things are becoming, more connected. The problem there is leaving that data unencrypted, you can man in the middle some of those systems. So you could alter the data from those types of systems, pump it down into the medical record. Now, that becomes data integrity. Once you get to data integrity issues, what you see, there's plenty of research out there already on someone that goes and presents for treatment. So if Adam went and presented, under my name for treatment, there's plenty of research down there for medical identity theft and those types of things that result in mistreatment, misdiagnosis, being prescribed the wrong medication. So that's kind of some of the risks that could potentially alter, patient safety, not just patient privacy aspect. So finished that first phase of research and got a lot of good feedback on it. We do understand that these issues are there, as you know, but we firmly believe that these devices are segmented in our internal network and they're absolutely not accessible over the internet. And I had numerous emails just standing, tall and wouldn't budge that that's not the case. Well, I knew otherwise. So I worked with another researcher, Sean Merdinger. We gave a talk on some of this that we're going to cover here at DEF CON last summer. And we went out to look at internet-facing devices. So what's the issues here, right? We have systems that are both directly connected to the internet, and then we have kind of indirect exposure, which I'm going to show you here coming up through some Shodan searches and queries that we've ran. We also, as this connectivity is growing, we're seeing cellular connectivity. So some external defibrillators that are, for example, inside of ambulances, they're sending like 12 lead information and those types of things to the receiving ED. So very good reason why they do it, but they put it on public cellular. There's some other issues about this, connectivity thing of, manufacturers need to do a better job. In some examples, it's like they have Bluetooth, they have 802.11 Wi-Fi, and they have cellular connectivity. Like, can't we pick one of them and reduce the attack surface? It's crazy, right? It's just bolt on everything. So we got to get better at doing that. And finally, they're being put in a very hostile environment, right? A known hostile environment when you put them out there on the network. They aren't segmented off necessarily inside the network because we need to start pumping data into the medical records. Healthcare organizations are becoming flatter and flatter. So it's not like this really isolated. There are some sections that are, well isolated, but for the general part, and I'm going to show you some examples, I think it's kind of a misconception that we have. So we were on Shodan, and our initial kind of goal to look at stuff was looking at direct on-net internet-facing devices. Now, we did find those. We talked about those at DEF CON. Those were everything from, fetal monitors to linear accelerators to glucose monitors to external defibrillators. But also, when I began this search, I did a search for anesthesia. And kind of popped up in Shodan. And other than it being a Windows XP system, there was really no indication that it was a medical device, right? So I knew that it wasn't a medical device. And I realized when I looked at that actually it was coming through SMB. So it was information was being leaked through SMB and also had anonymous read to their internal Active Directory. So this first system we came across was a large U.S. healthcare organization, over 12,000 employees, over 3,000 physicians, large cardiovascular neuroscience institutions, which you'll see in the results that I show you. Exposed intelligence through that misconfiguration on over 68,000 of their systems. And it also provided direct attack vector, which I'll talk about how that works and how that chains to all of those 68,000 systems. That wasn't just medical devices. I looked at it for medical devices, but this was every system inside their internal network that you could pivot directly from the exposed system. And also, when you look through the raw data, what you would find is we found indicators of common third parties. So organizations like lab services or radiology reading organizations that do third-party services to the provider, those were also in the data sets. So did we find one organization? Was it just this one that I happened to stumble across? No, we didn't. We found hundreds. So some of this is kind of scrubbed out. Some of it's not. But you can see here where we're going with the search examples. Just looking for SMB, and then we're looking for org identifiers. So you can see here, like we would do health, clinic, hospital, medical, the number of hits that we got for this misconfiguration that exposed system information. Once you change that term, so if you go to like specialty clinics, so if you change those search terms to like podiatry, pediatric, urology, those types of things, you end up with thousands of them that were sitting out there. So, why do we care about SMB? Well, as I said, the system also happened to be Windows XP that was vulnerable to MSO 8067, which, as we know, is SMB exploit. So now we have an external facing system that's leaking this, and we know it's talking back through a known exploit that's been out there for, 8 years, 7 years. So why does the information we're going to show you really matter? It's a goldmine for adversaries. It's a goldmine for attackers. It's got specific medical device information and applications. It leaks the host names of what those devices and the supporting systems they're associated to. And you'll see in some of these examples, it oftentimes leaks this actual floor, the office, the specific OR room number, physician name in many cases, and also tells us, because it has the anonymous read from Active Directory, if there's a system timeout exemption. So we know that the system isn't going to time out. So let's get into some of the data and some of the searches. So this first one on the left, this is something with the system lockout or a timeout exception. You can see the screen lock is set to 0. The screen lock 0, then we know it's probably not going to require login. Over on the right, this is the medical record system. So I do want to point out this example happens to be Epic. This is not an Epic issue. This is the healthcare organization misconfiguring their edge network and exposing these systems. This is not an Epic issue that Epic can fix. But if you know about Epic, there's some interesting things in here. One, this is all the servers that run Epic. But if you get down to like 3 from the bottom and you see My Chart is where you as a patient go through the application to access your patient record. If you get up towards the top, towards Clarity and Business Object, this is where all the third-party reporting is done from the database outside of Epic. So there's going to be a lot of PHI, that type of information in there, as well as hyperspace, and those systems are actually core function of Epic and the actual systems that run that medical record. The top one is actually an analytics server for Epic as well. All right, let's get into some devices. So here you can see over on the left, I've scrubbed all of these out. I actually did work with DHS ICS cert and the affected healthcare organization. It was the first time DHS ICS CERT actually had a security researcher that coordinated with a healthcare provider. So obviously, we've coordinated with DHS and device manufacturers, but this was the first time that we worked that coordination between a researcher and an actual healthcare provider themselves. And it went very good. They shared, full incident response details, acted appropriately. I won't go into detail on that, but they did respond. So over on the left is the host names of those systems on the network, and you can start to see more of the information. Up top, this is really PACS imaging. So PACS imaging, what that is in radiology, all the radiology systems, so the CT scanners, the nuke imaging systems, the X-ray systems that you work, they go to an archive system that holds all of the images. So you can see, like, the top one is probably like a PACS room, like a reading room where they would view those. The other ones are, you can see, like MRI or CT type systems here. In the bottom, telemetry. So these ones, you can't tell exactly what type of devices these are hooked to, but devices that run on telemetry are typically associated with, like, infant abduction systems. So when you get the band and you have the baby and it goes through it, locks down the doors and all those types of things, or wandering adult patient care. So I said they had a very large cardiology institution. So these top ones, you can see some of the examples of doctor, and yes, it had full doctor name. It would show their office number. You see Adrienne, whoever, and you can see cath lab machines. That bottom one, that pacemaker, was actually labeled pacemaker controller. So that was a little bit concerning if you do research into how pacemaker controllers operate. If you actually get your hands on a pacemaker controller, and there's a system like a pacemaker or a defibrillator within near-field communication to associate with that, the controllers, they don't require authentication. And that may be startling, right? But again, there's a good, we don't want two-factor authentication like, oh, I forgot, or my finger got chopped off and now I can't, deliver a rescue shock to you. So those are some of the types of the challenges that we get into when we get into those types of systems of, yes, we understand the risk, but make sure you're doing enough digging, like if you're going to do the research, to look at the solution and, like, the feasibility of it. So even, like, implantable defibrillators, I've seen some research that comes out like, well, let's just throw encryption on the defib. Great solution, guy. Did you ever think the thing runs on a battery and we're going to have to open up your chest cavity every 3 months instead of every 3 years? You're probably going to die from infection. So, make sure you think about those types of things too if you're looking at this. So, what are those feasible solutions? There's a reason why a lot of this stuff is done the way it is, and that's what makes this more challenging, I think, coming up in solutions. But it's also more rewarding when you fix them because it does, impact patient safety. So second's kind of pediatric nuke medicine. And down at the bottom, this is anesthesia. The very bottom one, anesthesia workroom. Okay, you can make a case that, yeah, that's just probably, like a nurse's system. But that top one, anesthesia OR. If you know anything about how the OR environment works, there's not just extra computers just laying around the outskirts of the OR, right? It doesn't happen. So this is most definitely an anesthesia workstation that's tied, to the anesthesia cart inside and assigned to the OR. So we found a few devices. Well, no, that was just the example of the one organization of thousands. We dumped all of the raw data on those 68,000 systems, used our favorite data analytics tool called Excel, did a fancy query called Control-F, search and find, and identified some of these, systems that would flag. And so here's what we found inside that one organization. So as you can see, very large, cardiology, cath lab type stuff, pacemaker type systems. PACS systems, very interesting. I want to talk that one really quick. I think a lot of medical identity theft, if it's not going after the medical record itself, is coming after PACS systems. So PACS systems, if you log into them from the RadText workstation, through the application, you actually have to log in with a unique username and password. But on the back end, if you actually hit a lot of those storage, almost every vendor that I've researched, you can go back in because there's no NTFS permissions on it. The ones that do have and require authentication, they're using an interface call between the application and the back-end storage, and it's hard-coded credentials that are sitting in technician manuals. So I'm going to turn it over to Adam quick to talk about some of the attack vectors with that type of information.
Cool. Yeah, so potential attacks. So sometimes you have to break it down for these organizations in terms of what could happen, right? So it's like, okay, yeah, you have information on all our computers. Great, wonderful. What's that going to get you? So here's an example of a physical attack that could be carried out with some of this information. So typically, if you're going to do, a physical pen test, obviously you can do some reconnaissance. This is like a treasure map, right, to exactly where you need to go. So here we know, for example, again, from internet accessible information, we have, what types of systems are in their organization, so what could be of interest to us. We know the organization name and the address. We have the floor, room numbers, office numbers, the people's names that are going to be on the door. And we also, from the same information, can tell which of the workstations have this exception to a screen lock. So it's basically telling us, go to this room, this office, this computer isn't going to ask you for a password, right? I mean, that's the impact of this for a physical attack. Go in, go out, you're done, right? Super easy. So from a phishing perspective, right, a lot of times it's still kind of risky to show up there in person. So from a phishing attack with the same information, as I said, you have some very detailed information that you wouldn't necessarily find on LinkedIn, right, to do very specially crafted phishing messages. You know the name of the machine, you know the location, you know what specific device it is potentially. So you can send a very crafted message, such and such host needs to be rebooted, click this link to do it, right? Someone's going to, okay, they must know what it is. Who would know what that, Bobby server is, right? So they'll click, and then you could develop a very targeted attack specific to the medical device. Again, there's hard-coded credentials in vendor manuals, so you know exactly what URL you need to hit, what parameters you need to pass it to conduct this very targeted attack. So and then there's obviously the pivot. So as Scott mentioned, there's the system sitting out there, this Windows XP machine, vulnerable to MS-08067, great. But as you can tell from the information returned via SMB, this is connected to the broader corporate network. So you can go in and you can pivot from that machine to another one of those machines and hop around in the network, again, using the very specific information that you were able to pull down. Host names, that type of information, what particular medical device it is, so you already know what types of vulnerabilities it will have in advance. So this is a situation where, okay, maybe the PACS imaging system isn't sitting directly on the internet, but it's 1 or 2 hops away from a system that's connected to the same Active Directory infrastructure. It may as well be sitting on the internet, right? So now Scott's going to talk a little bit about application security, an area that's done really, really well, from what I hear.
Well, everything's done well. Yeah, so I wanted to touch on this a little bit. I'm not an AppSec guy at all, but I find some nuances that are a little annoying or disturbing to me. And so I'm going to show this picture and let you decide. I know this is a terrible picture, but if anyone can read that, do you see that post request? Like, are there any things that may stick out that have issues? Anyone? HTTP, yeah, that's the first one. See, I get all kinds of stuff. I don't even know what you're talking about, but that sounds interesting. See, I don't even find that one. But yeah, so what I see here, and you guys, AppSec people, may see other things. So I'm not going to tell you what type of device this is, but what I'll tell you is this is a common thing that I see across multiple devices. And what this one is when I went in and I logged into the web interface of this wireless medical device, it has hard-coded admin credentials to get in. So once I got in, I thought, this thing's wireless. Let me go and look at the config and see if I can figure out how to break the wireless. Hopefully it uses web. A lot of these old medical devices uses web. So I switched over to the network config, to the wireless config, and I was like, oh, man, it's using WPA2. This sucks. I'm not going to be able to break it as easy. So I thought, I wonder if this thing, checks any type of validation, and if I even have to change anything without hitting save on the config, or will it just pass everything for me? So I decided to do that and put a burp in between, and I hit save. Sure enough, full information you can see here on the bottom is scrubbed out. So it gave me the SSID, the hard-coded SSID, or the existing SSID, as well as the WPA2 keys. I was able to pivot, and you can compromise the internal network just because of bad AppSec there. The other thing is, if you notice this thing, it doesn't use any type of session management or token. So, yes, I needed to do a lot of stuff and figure out a hard-coded password in a documentation in order to get into it. But now let me think beyond that. What can I do with these types of devices? So I did a test. Basically took this post request, stood up a wireless access point, bridged it to the internal network, sent the post request with the new rogue like Wi-Fi Pineapple rogue AP, posted it, switched over, and now man in the middle of everything. So I could see, in those types of scenarios, you can see key information. You can grab all the information that's flowing through there, whether that's a medical device integration product that has this issue, whether that's an infusion pump that potentially, you get PHI information, or you can see like drug libraries getting pushed out over the network, those types of things. That's what happened here. In addition to their internal network that they put WPA2 on is now completely compromised. So you decide if it's an issue or not. It's just Adam quick.
Yeah, no, that all sounds like good AppSec to me. So I'm also not an AppSec guy. I think it's good.
I'm an AppSec pro.
All right. Okay, so let's get into some more of the issues. So we talked, a lot about some of the technical details of this stuff. So what are some of the core, what's a diagnosis? If we're looking at these as symptoms of a disease, what's the underlying fundamental condition that we want to hope to address? So the most obvious one that we talked about here is that we have these exposed vulnerable systems that are out there. And in a lot of ways, this shouldn't be a surprise, right? We have these systems that are running software, and maybe previously they were using solid-state electronics to do what they do. Now they're running, embedded Windows or Linux or something like that. So they're software, so they're going to have bugs, right? So they're going to be vulnerable to those bugs. And we're also putting them in positions where they're not really sufficiently defended on the network side. We're connecting them to wireless networks. We're hooking them up to cellular connections. So when you think about that connection, we're opening the attack surface, right? So we're taking, again, a device that previously had no external attack surface, and we're just putting it out there and hoping that nothing goes wrong. So what may be pitched from the vendor as, oh, we're going to give you this, excellent software-driven, connected medical device is really essentially a vulnerable, exposed medical device, right? So that's getting to some of the root of the issue here. And secondly, there's just this lack of patient safety focus. When you do look at some of the security that is on these devices, a lot of it comes from the privacy perspective, which is great. I like my privacy. I'd like to be alive to enjoy it, right? So that's fine. We need more focus on the safety issues from these devices. There's also the awareness in getting a sense for what's the extent of the problem, how far is it spread, and why. So the first thing to recognize is, this is just the tip of the iceberg that we've found so far in this research. This growth of connected medical devices is growing and growing every year, right? It's just accelerating. And the reason for that is healthcare overall is accelerating, and it's the nature of healthcare that you want to have, you want to serve the patients in as many ways as you can. You want to get information to the doctors as quickly as you can. So it's just the nature of this, of healthcare that's going to accelerate this growth to begin with. So you're going to see a lot more of doctors walking around with iPads, which they are already. And okay, those were introduced, oh, it's just a monitoring function. Okay, well now it's monitoring and I can prescribe a drug for it. Okay, now it's monitoring and I can approve this. Now it's monitoring and I can just turn the dial on this pacemaker, right? So there's a trend that's going that we have to be aware of. The second is, so we have HIPAA. How many of you are familiar with HIPAA? There. Okay, so most of you, right? So HIPAA's got a great focus on privacy of information, but zero focus on patient safety. So the focus of a lot of these healthcare organizations has been, for a number of years, how to comply with HIPAA. And it's all about HIPAA compliance and what are we going to do to comply with HIPAA. And if it's not about complying with HIPAA, then it's on the back burner. And that doesn't help this problem at all because it gets in the way of a real risk analysis, which would say, look, we have this problem and we leak some patient information. That's terrible. But we have this machine, this infusion pump or this anesthesia machine that's accessible one hop away from the internet. That's a really big problem. So there's that going on. Also, the FDA, we'd normally think, okay, here's an FDA-approved device, right? It's in the hospital. It must be safe. And it's safe in a lot of cases, but the FDA has even come out and said they're not doing testing for these cybersecurity issues. It's just not in scope, right? So if you can imagine that, it's like, you have a security organization, tells you that a computer is safe, but they didn't actually look at the software on the computer for security issues, right? I mean, yeah, the computer functions, but how safe is it? What vulnerabilities is it exposed to? And then the last thing to think about is some of this problem area is a lot of people will dismiss this as, yeah, but what hacker is actually going to go after, a patient's infusion pump or pacemaker, right? That's, attackers are motivated by, by crime, by greed, by money, maybe some political motivations. But what's going to possess somebody to go into a hospital and say, OD all the patients, right? The motivation isn't there. And so, we think, sorry. So the question is, if an attacker were motivated,
how would you detect
how would you detect it? And the answer is you can't in a lot of cases.
Right now. So that's one of the big issues right now is that we kind of have low assurance that an incident has happened. We don't know. How do you prove an incident's happened? You have forensically sound logs and evidence. We don't have evidence capture. We don't have forensically sound logs being built in the medical devices. What we do know is every year the FDA, in quotes, several 100,000 reports of medical device associated patient safety issues, adverse events, and loss of life. And those are only adjudicated clinically. So if you die on a ventilator, they'll say, oh, you're pneumonia or whatever. Then it'll go into a generic device malfunction. But it never goes to, is it a security incident? And we don't have logs or sound data to prove that, so we don't know. So to me, we have low assurance. We don't know. And unintentional, they get malware all the time. And unintended, okay, it was going after, financial information, but did it hiccup and boom, it, changed some setting? Those are the types of things that Adam's trying to, mean here by malicious intents, not prerequisite.
Yeah, exactly. And I think that that's part of where the people miss the boat on this. You put these things on the internet, and if you've ever experienced, putting something on the internet and watching how it gets hit, that thing will get hit within minutes, right? There's people scanning the internet all the time for all kinds of things, and they may not be trying to, hit your anesthesia machine on a debug port on port 8888 or whatever, but they happen to, and that happens to cause an issue. So we've talked about, what are the problem, the extent of the problem. So we'd be remiss in not actually trying to think about what is some of the solutions. So what's the treatment plan for this if we were going to prescribe something? So there's a few points on this. So the first one, which is what we try to convey coming here and also at other conferences, is like, it kind of falls on us. There's not a lot of other people out there doing this, and as a security community, we need to be looking at this issue. We can't expect somebody else to fix this problem for us. This is a problem that affects you, right? So you should be hopefully invested in the solution. So you actually need to get out there and start researching, start talking about this problem in the organizations that you're in. Also from an education perspective, the stakeholders need to understand some of the prerequisites for connecting these systems to the internet or adding additional software functionality. So it's not that you're telling them, no, you can't do this, you cannot add Bluetooth to this, but maybe saying, you can do this, however, before you do this, we need to do a top-to-bottom inspection of that Bluetooth software stack. We need to understand what are some of the security controls that are going to be in place against these potential attacks, right? So they need to understand that before they get into the decision-making process about adding that feature, not 3 years later when they're finished with development and they're asking for a security review. The next one is getting multi-stakeholder teams and collaboration going. So as I said earlier, it kind of falls to us, but it's not on us alone, and we can't do this alone. We can do some of the research, but we need people from the FDA to assist, with potential regulation in this space. We need the device manufacturers to get involved in this. We need folks that can help see all the sides of the issues and put pressure on each of the pressure points that can allow this change to happen. And then finally, where we can, we have to emphasize that we're not necessarily asking people to do something completely new, right? What we want to do is try to get security integrated into processes they may already have for quality control, for vendor procurement, so things that are already in place. How can we inject security into those processes? So a few pictures we want to paint. So we have the current state, and if we just let things continue as they are, as Scott said, there's several 100,000 of these unknown incidents with medical devices each year that are piling up. There's no evidence capture capabilities. So as all these new devices with software being connected to the internet are introduced, there's no evidence capture, so we won't even know if they were, hacked. We have new devices coming to market with long-known defects. I mean, there are literally manufacturers out there today releasing their new, Bluetooth-enabled device 3.0 that has the same vulnerability as Bluetooth-enabled device 1.0 had from years ago. And then we have new devices coming to market, new ideas, right? You go, I was at the hardware store the other day, and I was just looking in amazement at the number of wireless locks and wireless everything that you could get there. And this is only going to continue, and consumers are going to only be, and doctors are going to expect that type of thing, Oh, why can't I, give this patient a shock from, my iPad, right? So that's going to be, there's going to be more of these coming out. And unless we do anything about this, we're going to be stuck in this situation years from now where we have tons of deployed devices that have some fundamental security issues. And not only are we dealing in a space where those adversaries that may not have the motive today, their motivations are changing periodically. They may find that this is an acceptable thing. Maybe they want to hold a hospital ransom, or they're going to disconnect all its, drug infusion pumps, right? That could be a viable criminal option for some organization in the future. Also, this increase in incidental contact. And what happens when you double or triple the number of network-connected medical devices in a hospital and combine that with people constantly scanning the network and all other kinds of tools that may be present for monitoring on that network? There's just going to be incidental contact and incidental attacks. So what's a better way? So what's a better future? So that previous future sounds pretty sucky. I don't want to be in a hospital in that future. So what's this model? So we take back patient safety as the overriding objective. And this should resonate with a lot of healthcare providers. It's key to them. But okay, before we think about how convenient it is to add this device for a doctor or add this feature to a patient medical device, think about what the patient safety impact is. And avoid, through education, repeating the mistakes that all the other industries made 10 years ago. I mean, things like default credentials, unencrypted communications, all those things. What have we learned and how can we apply that here? Engaging stakeholders, as we mentioned, getting the safety into existing practices. So we feel like if we do that, we'll be in a much better position where we have these medical devices out there that are more resilient to these types of attacks, a future where there's a lot of collaboration and ongoing conversation in this area, because this, as you know, security changes on a daily and weekly basis. And finally, medical devices, they're connected medical devices that are resilient not just to attacks, but also to, accidental, electronic mishaps. And Scott has a story, an idea how to do this too.
We just wanted to end on a positive note of how not to get your medical device hacked. And so I lived in Minnesota previously, and this is an actual picture I took. This isn't some stock photo or something. I had to actually drive around the block 3 times, the underarm through my car window. And so you can see, this guy's got the infusion pump, but he's definitely not on the hospital Wi-Fi, and that dive bar probably doesn't have Wi-Fi. But if you look really close, in his right hand, he actually has a cigarette, and behind his leg, he actually had a beer bottle. So, maybe the smoking or drinking will kill him before, but I won't get into that infusion pump. I can tell you that. So how do you get involved, right? How do you, if you want to do this type of research, before we wrap up into questions, acquiring medical devices, those types of things. There are some, regulations on what you can buy without a prescription, those types of things, but they are available on the third party on eBay. There's another website called MedWow that has a lot of third party, reselling of devices. Get involved in the industry working groups, get involved in the solutions. So whether that's from the, working with providers or working with the medical device manufacturers or getting involved with, various things like the FDA, security working groups for medical devices. They recently released, guidance and those types of things. Get involved with those. go speak at a conference about, any of the research that you're doing. Focus on solutions. Make sure you're as technically accurate as possible, and focus it all the way to solutions so that you actually look at the technology, understand it, and don't make stupid recommendations like encrypt stuff that we really can't really encrypt right now due to technology limitations. And finally, if you're interested in the Cavalry, there's the website. Highly recommend you go check that website out if you're not familiar with that group. And I do want to say too, I'm going to go to questions here, but on a positive spin, there are a lot of the larger organizations have been developing larger information security teams over the last couple of years. So groups like GE, Medtronic, Philips, they really are working, and they are opening their doors and collaborating with researchers. So I can tell you, I worked with Philips. If you watch my DEF CON talk, they came out in July and said, hey, this is what we're going to do for vulnerability disclosure policy and process. And as of November, they actually released that publicly on their website. So they have vulnerability disclosure, and they were the first ones to come out. So that's opening the doors. Medtronic has recently, they're still working on formalized approach. But Medtronic, for example, if you go to their contact us page, right away it says, hey, if you're a healthcare provider and you have an issue, and it actually says, if you're a security researcher, boom, here's a dedicated method to get a hold of us and we'll get back to you. So they are working on the issues, right? There's a lot of these, legacy type systems, but they're working to make it better. But the big guys are the big guys. There's still a lot of small, medium-sized companies that run medical devices. So, hopefully we'll continue down this path of, collaboration between the stakeholders and things will start to get better because as mobile and digital health grows, this problem is going to amplify and be even worse if we don't kind of, learn from previous failed practices. So, any questions? No. Practices. Avoid failed practices. Yes, I will when he's done. Yep. Yep. So the short question was, HIPAA hasn't been effective. Would regulation be effective when it comes to security and medical devices, and would that work? I think the short answer, the approach that we've been taking, what we've been recommending is not to go that route. Try to get industry to adopt secure practices. But what does that look like? We've got to shift the stakeholders, and that's why we've been working with the healthcare providers, right? So the healthcare providers, they can incorporate certain requirements and validation testing of the devices prior to signing a contract with the manufacturer. And so like on the Cavalry side, I'm working and involved in like a procurement guide of what they can do contractually to tell the vendor, hey, we're only going to select you. This is now our requirement. Just like it was a requirement that it ran on VMware and then it ran with our, our thin clients, it's now a requirement and we actually validate it. And if you don't meet that, you're not coming in the door. And there's other organizations out there that have spoken publicly, over the last, year. So, Mayo Clinic, they're a big one. They've been working on it. It's a large organization that has a lot of, impact when they do that. Les Stoltenberg, he's a CISO down at MD Anderson Cancer Center. They also have done it and incorporated that into their procurement process. So as those things change, it kind of changes that influence. The FDA has kind of taken that hands-off approach because regulation isn't necessarily the answer, but we got to look at all those stakeholders and what kind of influences them and what are their drivers, and that's what we're trying to do. Anything else? No? We're all medical experts, device experts? Good. All right, well, enjoy B-Sides, and thanks, guys, for coming out. Have a good one.